So in this video, we are going to see exercise 8.3 from chapter number 8, Introduction to Trigonometry. So we are seeing problem number 1 and which says evaluate, and we are given 1, 2, 3, 4 set of trigonometric ratio expressions which we have to evaluate. Now let's focus first on the first problem. You can say it's sine and it's cos, and this is 18 degree and this is 70 degree. So sine 18 degree divided by cos 72 degree, and we have to find what is the value of this expression. Now we know that sine and cos are two trigonometric ratios which are related by complementary angle property. And what is that property? So that property is, so this is sine and this is cos, and these two are related to each other. Okay, these two trigonometric ratios are related to each other by complementary angle property, which says 90 sine of 90 minus, let's say, a is equal to cos of a. Okay, I can also do reverse. I can put cos on the left hand side, I can put sine here on the right hand side, and again cos and sine are related by complementary angle property. What is that? Same, 90 minus b is equal to sine of b. Okay, so this is the name of the angle. It doesn't matter whether I write a or whether I write b or whether you write theta. That is totally irrelevant. What is the main thing that you have to focus is that cos and sine are two trigonometric ratios which are related by the complementary angle property. Okay, 90 minus a. Okay, so now using this property, let's try to focus on this expression that is given to us. So I'm going to rewrite the expression. So let me draw a line here. Okay, and let me rewrite the expression. The expression is sine. Okay, so the expression is sine of 18 degree the whole upon cos of 72 degree. Now, if you observe the numbers a bit, let's try to zoom in. If you observe these numbers a bit, 18 degree and 72 degree, you can see their summation 18 plus 72 is equal to 90. Okay, their summation is equal to 90, which means we can use this property and try to do some conversions. So since we have sine on the numerator and cos on the denominator, either we make the numerator in cos or we can make the denominator in sine. Either of it. Either we can use this or this. Doesn't matter. So I'll go with the numerator. Okay. So I'm going to say sine of 18. So I'll just make an, okay. So sine of 18 degree can be written as cos of 90 minus 18. Okay, basically here, so yes, basically this is using sine of a is equal to cos of 90 minus a. I'm using that property. Okay, and then this will be equal to cos of, what is 90 minus 18? That is 72. Okay, so sine of 18 is actually equal to cos of 72. So I'm going to resubstitute this here. Okay, okay, let's write it here. Sine of 18 is equal to cos of 72, and thus if you resubstitute, let me, so this is going to be cos of 18 on the denominator. Oh, I'm sorry, cos of 72 on the denominator. The whole divided by numerator is cos of 72 itself, and cos of 72, cos of 72, these are exactly the same values. This is equal to a by a or b by b. So they will just cancel out each other and we are going to get 1. So the value of the first expression, which was sine 18 divided by cos 72, is equal to 1. So let's come here and I'm going to write it down here. This, okay, this is equal to 1. Okay. Now similarly, let's go to the second expression, which is tan and cot. So I'm going to rewrite this expression first. Tan 26 divided by cot 64. So let's come down here. Okay. So the expression is tan 26 degree the whole divided by cot of 64 degree. Now once again, just like the sine and cos trigonometric ratios, the trigonometric ratios tan and cot, they are related to each other by the complementary angle property. And what is that property? Exactly same. It's 90 minus a is equal to cot of a. or I can even say, so I can take cot on the left hand side of the equation and tan on the right hand side, and I can even say cot of 90 minus b is equal to tan of b. Okay, either way it's the same thing. So tan and cot are once again related with this complementary angle thing, complementary angle property. So again, if you focus on the problem that is given to us, this is the problem given to us, you can see that this is tan, this is cot, and 26 and 64, if you do the summation 26 plus 64, it's equal to 90, which means I can convert tan to cot or cot to tan in terms of using this property, okay, using these expressions. So let's go with the numerator again. I'm going to write tan 26 is equal to tan, oh sorry, so I'm going to convert tan to cot, and I'm going to say 90 minus 26, and denominator remains as it is, which is cot of 64. Okay, and let's continue. So what is cot of 90 minus 26? That is equal to cot of 64. So cot of 64, the whole divided by cot of 64. Again, cot of 64, cot of 64. The exact value doesn't matter. Okay, it will be 0 point something something. We don't care. But since the numerator and denominator are same, that is going to be equal to 1. So once again, for expression number 2, we have got 1 as our answer. So let's go here. Yes, and let's say this also is equal to 1. Okay. Now next, the expression number 3 is cos 48 minus sin 42. So once again, let's bring it down. Cos 48 minus sin 42. So I'm going to rewrite the question. This is our question number 3. Okay. Hold on, what was it? Cos 48 minus sin 42. Yes. So cos of 48 minus sine of 42. Okay. Once again, our first and the most important observation here is this 48 and 42. So the summation of these two numbers is 90. 48 and 42 is equal to 90, which means we can use the complementary angle property and convert cos to sine or sine to cos. Okay, so I'm going to directly do it. Okay, this is equal to, now cos of 48 can be written as sine of 90 minus 48. Okay, so you change cos to sine and you change this a to 90 minus a. That's how it works, and this remains the same, which is minus sine of 42. Okay, and now sine of 90 minus 48 is equal to, it is sine of 42, sine of 42 minus sine of 42. So that is equal to 0. So the answer of the third expression is equal to 0. Let's make a note here. Yes, so this is equal to 0. And now we have fourth and the last expression, which is cosec 31 minus sec 59. So let's bring it down here. Okay, cosec 31 minus sec 59. Yes, so let me try to draw a line here. Cosec 31 minus sec 59. So okay, cosec 31 minus sec 59. This is our problem number 4. Let me confirm, cosec 31 minus sec 59. Okay, now we can zoom in. Yes, so this is the expression that we have to evaluate, cosec 31 minus sec 59. So again, just the way we have, let me write down this important thing. We have sine and cos, okay, related to each other by the complementary angle. We have tan and cot that are related to each other by the complementary angle. Similarly, we have sec and cosec, which are also related with each other through the complementary angle property. Okay, so once again, the key thing that we observe from the given question is, don't immediately start solving the question. First, try to observe what is given and what are the numbers that are given to us. This is 31, this is 59. Summation of 59 and 31 is 90 degree, which is a hint that you can use the complementary angle property. So let's start with that. Let me draw a line here. Okay. So yes, so we have cosec 31. So I'm just going to rewrite cosec 31 minus sec of 59. Okay, I can convert cosec 31 as into sec, Okay, cosec and sec can be converted using the complementary angle property. So cosec of A is equal to sec of 90 minus A, but here A is 31, okay, minus sec of 59, and that is equal to sec of 90 minus 31 is 59. So sec of 59 minus sec of 59, and these are exactly same values, so their subtraction is going to be 0. Likewise, you can convert sec 59 into cosec. That will be cosec 90 minus 59, which will be cosec 31. So cosec 31 minus cosec 31 will also be equal to 0. So choose any of the trigonometric ratio that you want to convert. So once again, okay, so this also is equal to 0. Thus, we have successfully evaluated all the 4 trigonometric ratios that were given to us, and we have found their values. The key thing to observe is that the numbers which were given in each of the expression, their addition was equal to 90, and hence we have taken that as a hint and use it, and using the complementary angle property, we have solved all the 4 questions.